we are going to discuss about another sets of question. Okay, we'll move on to our first question right down here. If an aqueous solution of NaF is electrolyzed between inert electrodes, the product obtained is at anode. Okay, so this is a completely an electrochemistry related question. Okay, so here we are writing about the electrochemical reaction in sodium fluoride. Okay, what is happening at anode part? So in an electrochemical reaction of anode, we do have that the reaction between sodium fluoride NaF, which gives Na plus and F minus, which is completely on cathode. Okay, but at anode we have the oxidation of water. Okay, oxidation of water, which happens to be 2H2O plus O2 plus 4 electrons, right? This is the chemical reaction that is happening at the anode side of this electrochemistry. So the option for this question would be option number D, right? Oxidation of cathode. Okay, and moving on to our next question, the conjugate base of NH3 ammonia, right? What do you mean by a conjugate base? Have you studied about a conjugate base in an acid? Well, a conjugate base is when a protonated H plus ion is removed from that molecule. Okay, when H2SO4 gives the conjugated base for this is HSO4 minus, right? By removing a protonated H plus ion from that compound. Well, in ammonia it would be NH2 minus. This is the conjugated base of right? Well, in the case of what about conjugated acid of NH3, which means conjugated acid of an NH3 is when we add an protonated proton to the compound. Well, upon this, when we added protons, it will give NH4 plus, which is a conjugated acid, right? So the correct option would be NH2 minus. NH4 plus is a conjugated acid of ammonia. Moving on to our next question. Given the E0 rate of an Fe plus 3 and Fe2 plus gives plus 0.76 volt and the 0.055. Okay. So the cathodic reaction for this EMF would be Fe3 Fe plus 2 gives 0.76, right? And for that I2, anodic reaction would be plus 0.55, right? 0.55 volt, 0.76 volt. Am I right? Yes. So E0 cell for this reaction would be E0 cell for this reaction would be E cathode minus E anode, right? Which gives what? How much does this give? Actually, it might give like 19, right? Cathode minus anode, 0.19 volt. Sorry, 21. We get 21. So it gives 0.21 volt. E0 cell for this chemical reaction would be 0.21 volt. Am I right? Is this equation correct? So what is the electrochemical reaction for this? E cell is equal to, let me just remove this one, okay, from here. So it would be E cell is equal to E0 cell minus 0.0539 and RT, right? RT by NF is equal to, this is what the equation stands like. The number of moles of this is 2, so 0.C06 E cell is equal to 0.21 minus 0.06, okay, 06 by 2, which is 0.03, okay. Upon removing that, we get 0.21 minus 0.03, okay, which is option number NF. Just give me this one, okay. 0.21 is equal to 0.059 by 2 log Kc. We should find the equilibrium constant, this one. Am I right? Yes. We might get log Kc is equal to 2.41 by 0.059, which is log Kc is equal to 7. Kc is equal to 10 raised to 7, okay, which is option number A. Am I right? Yes. I have got that question. Moving on to our next question, which is, which of the following cases a chemical reaction is possible? Okay. So we do know that according to the electroreactivity series, gold, platinum are on the lower, which means on the lowest side of electrochemical series. So it does not react with the upper side. So we could rule out the possibilities of how much gold and platinum, which does not react and does not give up anything with the nitric acid and HCl. So we have this one. When zinc is placed in copper vessel, so zinc solution is, it could easily displace this zinc with copper, which is highly reactive than zinc. So it could happen on the option A, but the correct option would be silver nitrate. This is because that when the option when AgNO3 solution is stirred with the copper, okay, there happens a displacement reaction which gives CuNO3, copper nitrate twice, plus Ag, which gives a free silver element. So the correct option would be option number B. Okay. Moving on to our next one. With regard to photoelectric effect, identify the correct statement among the following. Okay. Energy of electrons ejected increases with the increase in the incident of increases in the incident of light. So it cannot happen be like it is energy. It does not depend upon the energy. It depends upon the number of photons of incident light. Okay. So it could be like number of electrons ejected increases with the increase in the frequency of light. So it could not all happen this one. We could rule out the possibilities of option B and C. Number of electrons ejected increases with the increases in incident light. This is because E is directly proportional to the intensity of light. So the correct option would be option number D. Let's have our next question. A gas mixture contains 25% helium and 75% methane by volume at a given temperature and pressure. The percentage of mass of methane in the mixture is approximately. Okay, we'll discuss this question. Okay, so we do know that the helium is presented at 25%. So we could supply that it has to be at STP, standard STP standard registration, and we could mass of helium is given by 25 by 22.4. Okay, 25 by 22.4, which means at STP level. Okay, which gives how much? 1.12 mole. Okay, mass of helium. Well, we will look after the mass of methane. Okay, when mass of methane gives like how much is the percentage of 75 with 22.4, which gives 3.35 mole, right? Okay, which we have moles of helium and methane, and we could determine the mass of helium. Mass of helium is given by how much? 1.12 mole into molecular mass of helium is 4, which is 4.48. Okay, 4.48 gram of helium is present. Mass of methane is given by 3.35 mole into, what is the molecular mass of methane? It is actually how much? 16. 12 plus 4 hydrogen, 16, which is 53.60 gram. Okay, so the total, we have to find out the mass percentage of methane. So here we could mass percentage of methane. We have like 53.60 by 4.48 plus 53.60. Have you any doubt on this one? This is actually mass percentage, which means mass of a single component divided by the mass of total component. We have determined the mass of methane along with the methane and the helium, which gives actually 92.28 into 100. Okay, which has 0.928, right, which has 92.28 percentage, approximately equal to the option 92. So the correct option would be option number C. We have discussed the mass percentage molecule and number of moles determining. We do know that at standard temperature we have 22.4 liter. So we could easily determine the number of moles in a given gas. Okay, we could by that given number of moles we could also find the mass of helium present in that, and with that mass we could also find out the mass percentage, right? So the option would be 92%. We'll move on to our next question. Yes, for an elementary reaction with 2A plus 3B, which gives 4C and D, the rate of appearance of C at a time t is 2.8 into 10 raised to minus 3 mole per liter per second inverse, right? Rate of disappearance of B at a t will be, yes, we do know that how to express the rate of appearance and disappearance in a reaction, right? 2A plus 3B gives 4C and D. We have to find out the disappearance of B, okay, with the given appearance of C. So we could also write the rate of the chemical reaction by minus 1 by 3 d by dt of concentration of B, okay, is equal to 1 by 4 d by dt of concentration of C. Okay, you are familiar with this one, right? Rate of the chemical reaction, which means this N is given by the number of moles. Okay, so by this we could also find the appearance of disappearance of B by 3 by 4. What is the appearance of C? Rate of appearance of C at a time t is given by 3 by 4 into 2.8 into 10 raised to minus 3. Okay, So 3 by 4 into 3, 2.8 into 10 raised to minus 3, which is option number B, 57. The question number 57, for an elementary reaction, okay, the rate of appearance of B, which is d by dt of B, is given by option number B, 3 by 4 into 2.8 into 10 raised to minus 3. Okay, this is the reaction. So moving on to the next question. A Lewis acid X reacts with lithium aluminum hydride, which is a reducing agent. Consider that lithium aluminum hydride is a reducing agent in either medium to give a highly toxic gas. This gas, when heated with ammonia, gives a compound commonly known as inorganic benzene. Okay, the gases. Okay, this is what you have to find out. What do you mean by an inorganic benzene? Okay, so we do know that the inorganic benzene is B3N3H6. Okay, this is the inorganic benzene we have been discussing about. Okay, shares a similar structure to that of what? Benzene. This is the inorganic benzene. Okay, this is the inorganic benzene we have been discussing about here. So in this inorganic benzene, this is isoelectronic with benzene also. Okay, which has the same number of electrons with benzene. So the question is, when a compound, the X compound, when treated with ammonia, gives a compound known as inorganic benzene. We have studied about the preparations of inorganic benzene in our plus 2. That is, when a benzene, a boron B2H6, which is B2H6 when treated with ammonia gives B3N3H6. Okay, so the compound would be what? 41 in this question. The poisonous gas that is emitted is B2H6. Okay, dibromohydride. Okay, B3N3H6. Option number B. Actually, we should not be completely depending upon the first part of the question. We could also extend the level of knowledge onto the second part, right? It is easier to find out the correct answer from the second part, okay, rather than the first part. We cannot determine the first part with that, okay. So we have to move on to the next part to find out what is the correct option, okay. So the Lewis acid X, which is here, is boron hydride. Okay, so the correct option would be option number B. We will move on to our next question here. Which of the following is not a greenhouse gas? Okay, which of the following is not a greenhouse gas? Here, the greenhouse gases are chlorofluorocarbons is a greenhouse gas. We do know that, which are emitted by the refrigerants in our households and many other industrial areas. So CFC, chlorofluorocarbons, is a greenhouse gas. Carbon dioxide, which increases the temperature in the atmosphere, is also a greenhouse gas. Nitrogen dioxide, which are produced by the automobiles and industries and in the sewer systems, is also an greenhouse gas. So the correct option would be oxygen. Okay, this is not a greenhouse gas. Okay, that was a simple question. We will move on to the next one. A metal exists as an oxide with the formula M.960. A metal M can exist as M+2 and M+3 oxidation state. Okay, we do know that. M0.960, the percentage of M+3 in this oxide is nearly. You have to find out the percentage of M3+. Okay, we do know that the sum of oxidation states in its M+2 and M3 and the free ion is equal to 0. So we could easily find out the percentage of M3+ in this one. So Well, we will move on to this one. A metal exists as an oxide. Okay, this is the question. So let us name that when the number of ions in M plus 2 is X, okay, and in M plus 3 is 0.96 minus X, okay. Are you familiar with this one? We know that the overall charge in both the oxidation states and the free metal ion is M plus 2, M plus 3 plus M is equal to 0, which is how much is this? Ions 2x plus 0.96 minus x into 3, okay, plus 1 into minus 2. We do know that the oxidation state of MO2 is minus 2, okay, is equal to 0. By this we could find out the oxidation state of x value. 2x plus 2.88 minus 3x, okay, is equal to 2. 2x minus 3x minus x minus 2 minus 0.88, okay. X is equal to 0.88, right? So this is the question. So number of M3 ions would be 0.96 minus 0.88, right, which is 0.08. Well, we have to find out the percentage of M3 plus ion. Okay, well, to find out the percentage of M3 plus, we have 0.08 by 0.96 into 100, right? Total number of ions, which is 8.33, okay. 8.33%. So the correct option for this question would be, yes, option number A. Am I right? Yes, option number A is the correct answer for this question. For the question number 47, 8.33%. Are you familiar with this one? This is simple basic concepts of organic chemistry, right? We'll move on to our next question. Silicon doped with gallium forms what type of semiconductor, right? We do know that the intrinsic semiconductors are formed by the doping of another type of element in the parent element. So here a silicon is doped with a gallium form. Yes, silicon has +3, right? Actually 3 valence electrons. Gallium has 4 valence electrons. So by this we could say that the dopant is lesser than that of the gallium. So it is a p-type semiconductor. For this, the 49th question, the silicon doped gallium would be a p-type semiconductor. Am I right? Yes. We will move on to our next question. Yes. Simple periodic table question, right? We should know the familiarity between periodic table. So the last element of the P block in the 6th period is represented by an outermost electronic configuration. What is the last element in the periodic table? Actually, we do know that it is OG. OG element is the last. We have to find out the last element of P block elements. It is the fluorine, helium group elements. So we do know that helium, neon, argon, radon. See, radon is the last element in the P block elements, right? So what falls under the category of electronic configuration in this? Radon, which is 4f14, 5d10, 6s2, 6p6. Am I right? This is the general configuration of the last element in the periodic table. 4s4, 5d10, 6s2, 6p6. Option number D. Right. We'll move on to our next question. Yes. This is an easy inorganic based reaction. Right. Identify the X in the following reaction. When a benzene molecule is treated with a chlorine, highly chlorinated molecule, we get what? In presence of an anhydrous aluminum chloride in a dark cold condition, which is in the absence of a light. Okay, we will have this one, which is a so here we have to decide what is the reaction. Excess of chlorination. Okay, when a benzene is treated with chlorine, we get (6Cl2) in anhydrous AlCl3. We get benzene hexachloride, right? Benzene hexachloride. Simple chlorination of benzene. That's nothing. There is nothing complicated in this thing. Okay, there is only a simple chlorination. When it is used at a lower number of chlorine, we get a benzyl chloride. Okay, so here we get benzene hexachloride along with 6 HCl, 6 molecules of HCl. So the correct option would be option number B, right? Here it is then treated with 6Cl2, which gives benzene hexachloride. Okay, there is a complete difference between these three. Okay, these two. This is wrong actually. We get a benzene hexachloride. Option number B is the correct one. Move on to our next question. Yes. A solution of silver iodide is prepared by mixing equal volumes of 0.1 molar silver nitrate and 0.2 molar potassium iodide. Which of the following statement is true? Okay. Solution obtained is a negative solution with NO3 minus absorbed on silver iodide. Solution obtained is a positive solution with Ag plus absorbed on silver iodide. Solution obtained is a positive salt with K plus absorbed on silver iodide. Solution obtained is a negative salt with I minus absorbed on silver iodide. What would be the correct option for this one? We don't know. Before doing that, we might write the balanced chemical equation of this reaction. Okay, when silver nitride, silver nitride is treated with potassium iodide. Okay, this then is formed to silver iodide. Okay, silver iodide plus potassium nitrate. Okay, this is the balanced chemical reaction for this statement. Okay. The amount of AgNO3 present here is 0.1. What about Ki? 0.2 molar, right? So here Ki is in excess. So the salt obtained would be a negative solution with I absorbed on the silver iodide, right? This is the excess thing found in here. So the correct option would be option number D. Salt obtained is a negative salt with iodine ion present in silver iodide. Okay. Our next question. During the adsorption of a gas on a solid. Okay. Adsorption of a gas on a solid. What would be? So, well, we could say like this. When a gas is adsorbed on a solid, it increases the temperature. So we could write the enthalpy of a reaction is a positive value. Okay, when a gas is resided on a surface of a solid, it does not vibrate, or it reduces its irregularity. So delta is entropy of the solution will become negative. Okay, delta is 0. Well, delta G is given by delta H minus T delta S, right? So delta G is also less than 0. So the correct option for this reaction, for this question would be delta G is a positive value. The only positive value here is B, option number B, right? Whereas on option number delta H is also positive, okay, and delta is also positive, okay. So option of a case, delta G is negative, delta H is negative, delta is also negative. So option number A is the correct option, okay. We will move on to our next question. The pair of electrolytes that possess same value for the constant A in the Debye-Huckel-Onsager equation, which is lambda m is equal to lambda naught m minus A root of concentration. Okay, this is the Debye-Huckel-Onsager equation. We have studied in the electrochemistry. Well, move on to this one. Okay, the pair of electrolyte that possess the same value for the constant. Okay, that is what we are thinking here. So the pair of this Onsager equation, this constant A depends upon the nature of the solvent, viscosity of the solution, temperature, and the number of ions and solvation effect. See, these are the factors that depends upon the concentration A in this reaction. So we have to find out what are the hence there is no what solvent is present. We have never specified the what type of solvent is present, so we could exclude that fact, and we will move on to this one, number of ions, right? We could say like that one, containing the same number of ions have the same number of constant value, where depends upon temperature. We have excluded that. Charges of the ion, we have discussing on that. Dielectric constant and the solvent are also excluded along with the viscosity. This is because there is nothing as explained upon the viscosity, temperature and the solvent. So we are completely depending upon the number of ions present here. Since we will assume that each case solvents are same, the factor is number of ions, okay. NH4Cl and NaBr, right, have same number of charges, okay. Hence this pair of electrolytes only have the same value of the constant A in the Debye-Huckel-Onsager equation, right? Lambda 0 m minus A root constant C. This A is same for both NH4Cl and NaBr. The remaining questions, NaCl has 1 chlorine, CaCl2 has 2 chlorine atoms. Well, both this MgSO4 2 minus, both of them have 2 electrons. So the correct option would be option number B, NH4Cl and sodium bromide. Okay.